Hydropolymers requested engineering company Metal to build a new reactor for their plant in Norway. Construction work started 3.5 months ago and took up 17,500 man-hours in total. No less than 4,000 meters of pipe were used in this reactor, which is 32 meters long. The diameter of this vessel is 4.3 meters. It weighs 250 tons. Once the construction and its platform are installed and completed in Norway, they will be about 8.5 meters wide. The company FHP was asked to transport the construction to Norway. Then the old reactor had to be dismantled, and finally, the new one had to be put in place. The company Heavy is a partner of FHP and was responsible for transporting the construction from Genk to Rafnes. Even during the first preparations, the transport and installation of this gigantic construction had to be taken into account. The final details were applied on site. After finishing the construction, the reactor was transported to the Albert Canal in Genk. The trip was 1.5 kilometers long and took about an hour. The lorry has 580 brake horsepower. At the front, its trailers have a 4-axle bogie with a turning table, and at the back a 9-line, which also has a turning table. The total length of the entire lorry is no less than 45 meters. The two cranes each weigh 650 tons and are counterbalanced at maximum capacity. It only takes an hour to load the vessel from the trailer onto the inland navigation vessel, which will take the construction to Dordrecht via Antwerp. During the first part of the transport, sufficient draft and stability are of vital importance, which is why 1,200 tons of sand were loaded onto the vessel. The sand was distributed all over the vessel to counter the upward pressure of the water. Without the sand, the ship would break. The total height of the construction above the waterline should not exceed 6.5 meters. The route's bottleneck is a bridge in Merksem near the port of Antwerp. It's 6.8 meters high, so there was only a 30-centimeter margin. The inland navigation vessel went on its way to its destination in Dordrecht. During its trip, work was already carried out on the sea pontoon in Dordrecht. This sea pontoon was the only option to transport the construction to Norway, because the plant in Rafnes doesn't have an offloading quay suitable for seagoing vessels to unload the construction in a traditional way. The necessary preparations were taken to secure the construction. This is called lashing and securing. First, the main body of the crane is brought on board. Then, the crawlers are fitted to the main body. Then the central ballast is also brought on board and secured to the main body. Boom sections, extra ballast and wood mats are also secured onto the pontoon. As expected, the inland navigation vessel arrives in Dordrecht. The two floating shear legs cranes, which weigh 400 tons each, set to work to transfer the load from the inland navigation vessel onto the seaworthy pontoon. In late afternoon, the pontoon is further prepared to start its sea journey. At night, the construction is packaged in shrink foil in order to prevent the salty seawater and wind from causing any damage. The Rotterdam port authorities state that this pontoon must be taken to the river mouth by a push tug. Afterwards, a sea tug will accompany the pontoon onto the North Sea to Norway. After a good 3 days on the open sea, the pontoon arrives safely in Rafnes near Porsgrunn. Strict safety measures apply to hydropolymers. The entire crew has to take an examination and a safety test before they are given access to the plant and the quay. Before the construction can be placed on shore, all chains and welds should be loosened. The construction is then jacked up by 4 hydraulic jacks. Each climbing jack has a capacity of 250 tons. This is slow work, as the result of each movement is only 10 centimeters. Fagioli is FHP's other partner responsible for the transport, lifting engineering and loading. As the landing key can only carry a maximum of 25 tons per axle, Fagioli's SPMT, its self-propelled modular trailer, is used. This trailer will safely offload the entire construction as it distributes the total mass over its 14 axles. It's not a simple task, as the construction center of gravity is 8 meters above the ground. The construction is a very precise and time-consuming task. The road trip between the quay and the plant takes about an hour. Then the construction goes through the entire unloading process again. Over the next few days, extra connectors will be installed to ensure that the assembly at destination will not take long. FHP's third partner, Pearson, supplied the crane which is responsible for all the heavy lifting at the plant. The crane's tracks damaged the road surface, which is why Fagioli's SPMT was configured to take the crane to the plant. Before the crane can be put in place, the ground is leveled with gravel and wood mats. The slightest deviation can have fatal consequences. The heavy technical crew help build the crane in the next few days. Boom sections and the hoisting cables are fitted and secured. Then the last few counterbalance weights are put in place at the back. First, the crane hooks are secured during the dismantling of the old reactor. More than 20 bolts are loosened and the old reactor is ready to be put on its supports. Fagioli's SPMTs come into action again and drive the reactor to its temporary resting place. In the meantime, the preparations of the new reactor continue. After a final inspection, the crane is ready to lift the reactor to its final destination. When the final bolt has been tightened, the reactor can be connected to the rest of the installation. Because of the favorable weather conditions, the positioning of the new reactor took 3 hours. The reactor was put in place within the agreed time limit. The customer and the crew members are very pleased with this successful project, to which FHP made a major contribution.